In our last lesson, we were looking at the surface area of cubes. Cubes are pretty easy because all 6 faces are the same size. Rectangular prisms are a little bit different. Still not too hard, but just a little bit different. So this is a net for a rectangular prism, and if we folded it up, you can see that it makes a rectangular prism. So just like a cube, this rectangular prism also has 6 faces, but unlike a cube, they're not all the same measurements. This is 4 inches, this is 3. If I turn it this way, you can see better. And they're not all the same size. This one is 2 inches by 3 inches, but they are in pairs. If you think about it, this top and this bottom match, this front and the back match, and the 2 edges match. So that can help us out when we're finding surface area. Rather than having to find all 6, we only have 3 that we need to find. A lot of times students stress out about which is the length. Is this the length? Is this the length? Usually height being up, most people don't have too much trouble with that. But really, if I turn the prism this way, did I change its size? No, I changed the order of the length, the width, and the height.
Alright, so here we have a picture of a rectangular prism, and it says, what is the surface area of this rectangular prism? So it's helpful if you designate which measurement is the length, which is the width, and which is the height. So for this one, 8 is our length, 3 is our width, and 6 is our height. It doesn't really matter, and you shouldn't stress out, because even if you turn this on its side, it would change which one's the length, which one's the height, which one's the width, but it wouldn't change the size of the shape. So you don't need to stress out too much about which one is the length and which one is the width. Okay, we have 2 different formulas that we can use. One is 2 times the length times the width. And if you think about length times width, that would be like the top and the bottom of this prism. 2 times the length times the height. Well, length times height, this is the length, this is the height. That's like the front and the back. And 2 times the width times the height. Here's the width, here's the height. These are like the 2 side pieces. So that's one way that you can do it. Another way that you can do it is you can find one of each. Find, for example, the bottom, the front, and one side. Add them together and multiply by 2, and that will also work. Because we haven't spent much time on distributive property yet, I'm going to focus on using this formula when I do examples. But if this one makes sense to you and you would prefer to use it, you are absolutely welcome to do that. So let's substitute the dimensions in. So now we have 2 times 8 times 3 plus 2 times 8 times 6 plus 2 times 3 times 6. When I multiply those out, I get 48, 96, and 36. Then I just have to add them all together, and I get 180 square inches. There's other examples back in the slides, and there are also other videos that you can watch if you still need some more help.
So that was our introduction to surface area of rectangular prisms. If you think about rectangular prism being like a box, and if you wanted to wrap that box or cover that box with something, with fabric, with paper, that we are on the outside of the box. That's what the surface area is all about. And if you think about boxes, they have matching sides that are opposite each other. The top and the bottom, the front and the back, and the 2 sides always match.